Hi, welcome to XReality podcast. I'm the host, Dominic Wu, and beside me is the guest, Alejandro Mendoza. Hi, Alejandro. Could you share a little bit about your background with us?
Hi, thanks for having me. Yeah, background wise, it's funny. I'm on an XR podcast. I actually never envisioned my career going this way. And it was for the sake of, a couple really influential figures in my life, both as mentors, but also coworkers. They kind of guided me to that direction. I actually started in manufacturing. So all the way back in high school, I was doing manufacturing in composites. And so at the local plant, I would go, after school on weekends and whatnot during summers and just learn all about composite manufacturing, glass fiber, carbon fiber, and just, the advanced manufacturing that happened with our products always interested me. In fact, we'd take like little road trips to go across the road to witness the windmill blades for the wind generation, Vestas specifically, company, and they were laying up with our composite in hundreds of hundreds of feet, and it was just, kind of got me that spark of what else can be done in an advanced manufacturing setting, and how can technology be integrated. And I bounced between some startups. I landed back in aerospace actually, with Ball Aerospace, now BAE, and was doing new product introduction for them. So kind of did some work on some legacy programs, and then on some cutting edge and new product introduction stuff, and then evolved that actually into commercial space. And there with Sierra Space, have been kind of full steam ahead on integration of technology, specifically XR, a little bit AI into advanced manufacturing.
Hmm. Wow. So yeah, it seems like there are a lot of very interesting, exciting things that happening in space right now. And as far as I know that China, right? China is about the space because I think I read a news. I'm from Taiwan, so that's why I'm very aware of those news. It seems like China, if let's say they attack Taiwan, they can use their whole entire Wi-Fi system or something, and doesn't have to involve with United States. So I think space before we thought like, oh, space is more like a go to the moon, go to Mars, but actually, I remember a long time ago I talked to somebody in SpaceX that said that actually SpaceX is a satellite company. It's yeah, they have a lot of satellites cover around the orbit, low orbit, or like a monitor and provide Wi-Fi for us. So pretty much, it's very interesting. We thought that space is more like a very far away that we would never think of that, but I think space right now, especially for military, is very very important because if you want to know what your enemy is working, doing, monitor them. I think putting like a satellite or something in space is very important, like the military strategy. So, what types of? Okay, go for it. Sorry.
Oh, I was gonna say, no, you're spot on there. It's like, well, we're not going to talk about anything specific. Space as the next frontier for warfighting is actually what most companies are pivoting to right now, especially with mandates from the federal government to gain superiority in that domain, such as detect and whatnot. Those constellations you mentioned, Starlink being, a public constellation, but also of use in conflict for countries like Ukraine. Constellations and their placement are certainly a tool of power in contested spaces across the world. And while it's critical to maintain superiority in those spaces. It's also exciting to talk about how normal people can benefit from both constellations, but also very intentionally designed satellite systems that, while may not be wholly encompassing, like Starlink, can provide um, concise benefit to scientific use cases. In fact, I just attended a forum um, that is the Quantum Forum here in Colorado. And it's a realm in which placing quantum capable satellites gives capability for advanced timekeeping, encryption, encryption key sharing. And these are all things that are going to be critical to the infrastructure of tomorrow, especially as quantum computing on the other end ramps up, and we're seeing, you know, traditional encryption not being enough or easily solvable with the power of quantum computing. That is just something like it's super interesting to me. Has absolutely nothing at all with like to do with my previous experience. So I'm not gonna say that I'm very um, knowledgeable about it, but it combines space, it combines advanced manufacturing, and it combines quantum, and all of these, I think, coupled with AI, are critical to building out the infrastructure, both militarily and commercially, of the future.
Yeah, I think, for example, like and I think for Trump, the government, right? They allocate a lot of budget for this types of like a AI, cryptocurrency, and also like a space, military. All the budget I saw or in my memory is like a budget is increasing. Yeah, so I think that this area will get a lot of like a budget-wise support for, yeah, yeah. So yeah, I mean, education got canceled. I mean, it's still in the process. I don't know. I feel like it's very different from Trump era versus Biden or Obama era. You see, like before, it's more like helping everybody to keep up, and now Trump era is more like that's like it's more supporting for elite. That's my thought, and make us like a strong muscular man and trying to attack other people. Which makes me feel like a little bit like that. But
Yeah,
anyway,
I think politics aside, it's critical to not only keep up with other countries. If we look at the education in this country, um, we're not so near the top in a lot of key metrics, and it's kind of worrying because previously, like look at other technologies that have changed the world. I mean, even flight, computing. A lot of these things were their origins were in the American education or post secondary or higher education. They're products of that, and in order to, continue along the path of not just maintaining, but excelling. Um, you need to make investments, and politics aside, the fact is that the workforce of tomorrow, they are under more threat than I think any workforce has ever been.
yeah.
I think supporting them in whatever way possible on whoever's political agenda is absolutely critical to our national security, but also to our identity as a country.
Yes, if you see like a recent news, you can see like a lot of recent grades. They couldn't get any offers or any, especially computer science graduates.
Oh,
So
yeah.
yeah, so I do feel a lot of concern because young people, they are the future of our nation. And if they are struggling, then what should we do to help them? Yeah, it's very interesting in this era because a lot of tech, you see, like all the tech leaders. I remember Sam Altman. I saw one of his interview. He mentioned that this is the best era. I wish I could be like a 21, 22-year-old college kid so I can
Yeah.
create my own thing. But
Yeah.
I think it's very, very competitive. For example, I can just use ChatGPT. I would say like my um, coding knowledge for web development, such as React, is very bare minimal knowledge. But I was able to create some interesting functions quickly, just like a 1 day prototype. And I was shocked how, even though I don't really know, but if I can imagine, I can ask, I can build it. So it's a very interesting era because you can see like, oh, for young people, they are so empowered. But on the other side, it's like, oh, AI that couldn't really enter to any workforce now. Yeah.
Mhm. Well, in that way, I would agree. It is more exciting now than it ever has been for young people, but only for specific instances. And those instances are you have peak creativity typically like when you're younger. You're not jaded in any way or told by managers
Oh,
or that you
yes.
can't do something.
Yes.
In reality, like as a kid, I always wanted to, learn about, of course, a lot of young boys like video games and graphics and coding. A lot of that, while I had a computer in the home, my dad was a photographer, like really pushing for digital literacy. Some of those higher order functions like coding and whatnot were beyond the scope of my education.
Mm,
And the ideas that I had, while, not particularly novel, they wouldn't have made the next trillion-dollar company. It's also just critical to pursue those ideas so that you learn from them. And that's where I think AI empowers students today because the world's your oyster and you may not doing like the code that you generate alongside AI, hopefully alongside AI, not
yeah.
with
Yeah.
AI, can unlock some amazing functionality. It's just more about the problem than it is about the solution of learning to code in that
Mhm.
specific language. You can actually make up for those gaps with the technical expertise of AI, and it's only going to get better.
Mm.
But kids need to realize that that makes their primary value statement their creativity and
Yeah.
their problem solving, not necessarily their technical know-how.
Yeah, it's very interesting. I remember in my class, one student said that, wow, right now using AI, it's like, is this cheating? Using AI to code. And my reply to him was that long time ago, in computer science, for coding, it's more like the developer talk to the, computer's language, like C sharp, right? The developer need to learn how to talk to computers. So developer learn C sharp. And by turning humans language into C sharp, and type in and computer understands. So computer then execute the way that the developer intend. But now computer is learning how to talk to human. So instead of we are trying to learn how to talk to computer, and computer is now can is capable of talking to us using human language. So whatever you want to do, you just talk to it. You don't, you still probably right now, I think right now is the bridge. We still need to learn how to talk to computer. So you see, like, for example, you are talking to somebody who speak Italian, right? Or French, right? And if both of you can learn each other's language, it's probably easier for you guys to come up with or the other person know what you want, right? If you only know English and that person has to speak English, and there might be some translation problems. So yeah, by having some some learning, you learn little bit of the computer language, and computer know your language, and by doing so, you can pretty much, if you have idea, you can computer will know. So it's more like a media before it was like the developer talk computer's language. Now is computer talk human language. So human can use human language to talk to computer.
No, the natural language programming revolution, I think, is here. And furthermore, multimodality. I actually wrote a paper about this within Sierra Space internally, called the convergence of AR and AI, and that is AR being a blanket term, XR, VR as well. In general, sharing multimodality um, with AI allows us to even go beyond natural language programming instead to spatial understanding. And spatial understanding can be used to relay problems that, if I'm going to define, I have a problem with a very intricate detail that may be hard to like document. Like you can document it, but you're going to write paragraphs on paragraphs. Like showing it and then having a conversation about the issue is a lot easier than simply just even typing out a whole nonconformance about it. So I think that we're in a pretty miraculous era, but to apply tools, we're given a lot of hammers, and really there's many different types of hammers, right? Sledgehammer and ball peen. You're not going to apply them in the same manner, nor should you. And so using the hundreds of billions parameter sledgehammer that runs on, AWS servers to solve something like summarizing your email, maybe not the best solution or most secure solution if you're not doing so in a FedRAMP way. But I think there's just so much increase to that. And I think that gaining literacy, not only in digital literacy, but like AI, XR literacy is critical to actually the advanced manufacturing of the future, but also many different job types of the future.
Yeah. Can you give us any study cases or any user cases for example, like space training or space education or yeah, like anything that you guys or according to your knowledge, that in space industry that utilize XR and AI, like spatial AI types of solutions for space industry.
Yeah, I mean, I'm really standing on the shoulders of giants here. It's been the use of um, XR for
Mm,
spatial understanding, AR for spatial understanding, goes back quite a long ways. Some big names are like Shelley Peterson. Um, she in within Lockheed Space really led the way in work instructions and reducing cost of installation of components with object tracked placement. Things like that can save millions and millions of dollars. And what I'm trying to do actually is push earlier into the design cycle because we're a younger company, push all the way into, CDR, PDR. Why don't we evolve the designs with that spatial understanding? So we have designers interfacing with technicians so that when they have an advanced assembly, the technician who has the experience, decades of experience with assembling space, um, you know, advanced either satellites or spacecraft, can then relay to the designer, hey, look, I know that it seems to make sense in 2D to build it with this, you know, uh, order in the case of manufacturing, or for astronauts to build this and design this in this manner to give them the shared experience of being in the design space. That feedback becomes immediate. It becomes obvious in a way that it wouldn't in 2D. And one of the most um, awesome examples I've seen of that was Dr. Tom Marshburn at Sierra Space, when I had put a headset on him with our latest life, um, our large inflatable habitat design. Um, he immediately sets it on his head and starts taking biomeasurements. He was measuring it based on his, expertise and his experience being an ISS astronaut. And with that, was immediately able to draw conclusions about the payload wall design. And, I've mentioned it before in other arenas, such as at AWE, but that right there is something that the designers were not even able to do themselves. And right there is just perfect evidence for why we need to integrate spatial understanding all the way into the design of the very first assemblies, sub-assemblies of, a greater integrated system. Um, because there's no way to, even with your mannequin, they sometimes they put mannequins in these spaces in CAD, and to manipulate their poses and whatnot. It just doesn't quite summarize the the understanding one gains from being in the space. And not only the payload wall, but also the restraint system. So obviously, in order to affect something but not have it affect your position, you need to be restrained. Uh, like the foot restraints needed to be in both. It's funny because you say vertical and horizontal placement, but with that, there's no up, right? So if you have a habitat orbiting, you need to consider your restraints very carefully, especially if your manipulation points aren't like your payload wall aren't accessible with those restraint points configured the way they are. Something as simple as that is going to completely inhibit your efficiency and oftentimes your safety in space, and that's absolutely unacceptable to not account for.
Yeah, and especially in space, it has a very um, abnormal or not normal compared in Earth, right? Because I remember I play a space game and it's very hard to play. And they are doing like I remember SpaceX launch a free space game and it's a web, it's on website. And I was playing. The thing about space is that there's no friction or something. And it seems like if you keep moving and if you accelerate or something, it's very different from what Earth is. So sometimes if you do something and you couldn't even rotate or something, the physics is very different because there's no air or something. So it took me a very, very long time just to figure it out what to do. And yeah, I think by using AI and XR, it can really helps uh, uh, to simulate like a very similar like the physics types of things uh, to help astronaut learn more about like how to like be functional well in space area. Yeah.
Mhm. And I mean, we have amazing other innovations that have accomplished the same thing in a better way, such as the neutral buoyancy lab at NASA, like to emerge a replica of International Space Station underwater pressurized suits. And, it gives that sense of neutral buoyancy, like floating. However, like you said, you have friction in the water. Like
Yeah.
there's still like intricacies that are not going to be anything like the environment that you're trying to operate in. But to give, a taste of the physics, a taste of evaluating a design in that, on orbit environment with just a headset. I mean, it's not a full experience. It's not even, it's a fractional experience for sure. But
Mm.
it's, you know, the difficulty to bring that to the designers is minimal. It's game engine and custom executable, slap it on their head, and then change it like the next second, update it. Like don't even build, you know what I mean? Just keep it in play mode, make the change, and then push. That's the beauty of spatial computing and the speed at which we can move with these evaluations.
Yeah, yeah. I think for XR and AI, definitely it really helps to for the astronaut or people work in the space, really help them to kind of like immerse themselves into more like a realistic simulation, since a lot of things are very different. Yeah, and for space industry, what do you see like from training, simulation, digital twins, and smart manufacturing? For example, like you mentioned that there are a lot of interesting ways to simulate and how to do with the digital twins. How can those, um, for example, like from training to digital twins, what's the process you build for these types of flows?
Yeah. Again, another realm of technology and, integration of many different technologies that I'm not going to claim to be the expert in, but I'm actually speaking at a conference called Archon later next month, put on by Matthew Bird. And he has built his career around reality capture and reality reconstruction. It's something that has completely captivated my interest after I began building in AR, XR, VR experiences for work. It actually was a question that was asked of me by the chief engineer of our Dream Chaser space plane, Jason Hinkle. And he goes over to me and he says, how much of what we just saw, I was showing him an evaluation of accessibility for our non-destructive testing that had been, taking a little longer than it should have been. And so what I did was I floated an entire model down to the last, fastener um, in the room with us. And you've done XR3 headset, and then you have your hands occluded. You could use tools and actually gauge fitment um, and gauge accessibility, where the CAD view that was, because it wasn't as performant on laptops, was actually reduced. Like they had removed, I think, like electrical harnessing and some other subsystems, so it appeared very easy um, to accomplish what we had set out to do. But in reality, once you incorporate the full CAD, everything that would be in that location, when you consider the as built, then you kind of run into the issue of, does my simulation, does my practice, um, resemble reality? And so immediately dove into reality capture, and that is went about scanning, photogrammetry, and now Gaussian splatting. Actually, I've been all in on reality capture technologies, both for mesh generation as well as Gaussian splat generation, and then incorporating that into the workflow. Not to create digital twins, because I think digital twins is a very overused term. It,
Yes.
it requires IoT, which,
Yeah.
like, unless you have all of your sensors integrated,
Mhm.
don't have a digital twin. And
Yeah.
unless you have the actual condition of your assembly integrated in photorealistic sense, you don't
Mm,
have a digital twin. You have at best, a really great tool for evaluating a snapshot in time.
mm,
And the frequency, as that frequency steps up to real time, that's when you have a digital twin with all your sensors, photorealistic visuals. Um, and there's just not many companies, not many processes that dictate a full digital twin
yeah.
as a value add. However, visual twin, that's critical to manufacturing. It's critical to archiving builds, archiving essentially quality, so that when you ship for integration into a bigger subsystem, if you're not the prime on the contract,
Mm,
I want to make sure that I can perfectly reconstruct the state of my widget before it's integrated into the system. So if they come back and say, hey, look, your R32 surface was scratched, you can very easily say, no, it's fully documented. We can actually look at a model, you and I.
mm,
Let me just instantiate a WebXR environment, drop it in. It's like, okay, here's what we had before, here's what we have after. And to do that with essentially every subsystem and then stack them,
Yeah.
that's right there, ultra powerful. Again, still not digital twin, but so to respond to Jason Hinkle, kind of bringing the story full circle there, the question was, how much of this evaluation that we just saw the lead non-destructive testing technician conduct,
Mm.
how much is that of that is reality? How much of that is possible? And so within 24 hours, I hopped on a plane. Our space plane, Dream Chaser Tenacity, was just about to be dropped into TVAC in Ohio uh, at Johnson. And so I went down there, got on base, went with a phone and literally just conducted a nice sweep and recreated one of the bays, one of the most intricate bays, and um, generated the mesh and actually dropped it onto the CAD. Um, and the question was, what's the difference? And I was really disappointed at first. I can't tell you how disappointed I was because I was like, well, I can't really see much of anything. Um, and then, an idea sparked in my head. I was like, wait a second. I affected the positioning and I pulled it out towards me just a couple millimeters and it actually emerged from the CAD. And it's like, wow, that's how we know we're dealing with some of the best builders of these systems in the world is because it was so spot on that the um, the scan was nesting within the CAD. And so then I brought Jason Hinkle out, brought the CEO, several SVPs at the time, and showed them, here's the evaluation, everything's possible. We've planned hundreds of evaluations, and they're like, great. And immediately they asked the same question. So, how much of this is actually possible? Like, is this resembling of as built? And I just turned it on and then faded in. It was wild. I faded in the scan and it just like the textures, everything just went from flat CAD to an actual reconstructed mesh, a fine mesh, and their question was answered visually. It's very powerful.
Oh, wow. So, for example, for space, like what types of missions, for example, space need to get? I know for astronauts, what's ISS astronauts doing and what types of training they need to have? Like exercise, grow some plants, because I know they are trying to do some interesting, a lot of different interesting stuff. Anything like what's the astronaut like a day? Yeah, like what are they doing? I know it's so cool to be there, but a lot of people gather together. What are they doing?
Yeah, so doing with the technology, like I've actually met with several of the NASA facilities, VRXR experts, and they are using it in everything from manufacturing to astronaut training. But much like I have to do, and of course anyone who's actually gaining value from this has to do, is they have to be the first line of defense to say, no, that's not a good use case, but we can do it. We can, uh, replicate this finite part of the process. Would that, would that is that valuable? And the answer is either yes or no. And the creative problem solving to actually capture and construct parts of the processes that are valuable is where, this really is engineering. It's virtual and extended reality engineering, because to replicate, silly processes would take a lot of time and aren't very um, fruitful, actually applying fasteners. Like if I'm going to um, simulate screwing in a screw.
Mm,
That's just like, oh, well, if I account for friction and all that. And it's like, well, there's really not much use for that. But placement of, the click bond that fastener goes into, that's extremely valuable because otherwise you're setting up a whole Faro array of lasers and, it's a nightmare. And if you have robust tracking to just put something on your face and then place within millimeters of where you should be, and you didn't have to set up all that equipment, that right there is money saving and extremely powerful. But as far as the future, um, I think what we need to do is really automate and um, when we go and design new systems,
mm,
uh, do so not only with spatial understanding, but design the processes as well. So the manufacturing processes, like I said, bring in the technicians very early on,
mm.
bring in the astronauts. Um,
Yeah.
Everyone really should be in the same room for evaluations
Wow.
because every little choice made upstream has an effect downstream,
Mm,
and um, even if it is like, say, for example, a maintenance item. So spacewalks are one of the most dangerous things known to man. Like,
mm.
have you ever?
Well, how can you even walk? Because you are floating, right?
Yeah,
There's
well,
no
exactly.
friction, right?
They call them spacewalks, but there's nothing walking about. You are exiting an airlock and you are tethered, but floating in space. And to like during the construction of the ISS, and its maintenance, of course, is a very dangerous task. And to create and visualize, things like keep out zones, pinch points, but also to map out uh, the actual operations, the maintenance that needs to be done, and perhaps um, run through that time and time again as an astronaut who's going to partake in that spacewalk allows you to familiarize yourself. It's just actually it's perfectly I
Wow.
sleep great. And so, I'm not saying that's anything like being an astronaut, but the fact is, like, if your system with direct feedback and load cell pedals resembles um, your actual vehicle,
Mm,
and you're doing hundreds of hours of laps on a laser scanned track that resembles the track in its state and the ways that the water pools and the different textures, then you're able to, when it comes time to execute, do so in a safer manner, in an efficient manner, and accomplish the goal that you set for yourself. But that's the level of simulation with XR that needs to be achieved in order for it to be valuable. And it becomes more and more difficult to do so, like we said earlier, when you know um, not zero gravity but microgravity is in play, and there's all these other factors that you need to consider. But that's the challenge of virtual and extended reality engineering.
So do you do like, for example, like it's like people or astronaut wear the Quest 3 headset and have controllers, and then in the room and where there's some missions like gamified, and they need to get through before they really really go to the space. Is that the training case?
In the early days of life design, yeah, that was definitely the case. Evaluation, especially with eye track headsets. So I have some Vario products at work that track your eyes, and you can evaluate. Are the labels that I've placed for my emergency as well as my location schema going to enable efficient movement through my system? So if I'm an astronaut and there's an emergency on the other side of the craft,
Hmm.
can I, with no up and really a cylindrical circular design, um, navigate to one side and not be confused because it looks like a mirror of the other side? Can I find the labels quickly in my vision and then use that information to navigate around to, the opposite end and do so under high stress.
Oh,
That's the
yeah.
kind of question that, you don't want to find out how quickly you can do that when there is an emergency. You want to find
Yeah.
out and practice and refine the placement of those labels um, before it costs anyone anything.
Yeah.
Because, the time spent developing those experiences offsets potential emergency or, people being hurt later. That's way more than worth it.
Yeah, I remember a long time ago, I tried like a ISS, International Space
Yeah. Yeah.
Station, that VR game in Quest. I remember first I tried because of motion sickness, right? Whatever you
Yeah.
see and whatever your brain senses is different. Whatever you
Mhm.
see and whatever your body is located, if it is misaligned, then you will
Yeah.
get motion sickness. I remember when I saw, like, for example, I was grabbing those, bars and trying
Yeah.
to fly myself into whatever
Yeah.
cabinet that I don't know. And then because whatever I see is that things is rotate tilted because I'm floating. However, I'm
Yeah.
sitting or I'm standing. So that's why I got motion sickness immediately. So
Yeah.
as for astronaut training, are you guys like hanging there, hang them, and then once things rotate and there's like something like flip them or put them into the I know that somewhere there's like a vacuum space that for astronaut to practice floating in the air, like anti-gravity, something like device like that.
Yeah, not quite. I mean, uh, um, you can replicate by removing, the friction of the atmosphere in
Mm.
terms of suspension and, anti-gravity. That's what the neutral buoyancy lab is for. That's what the pool is for. We're not doing any of that in particular. But we have created things like offload fixtures. So there is equal force being applied upwards as there is gravity downwards. So you do get that feeling of, oh, this is a payload wall, and it feels weightless to you.
Oh,
Um, that right there is, a good sense of, can the mechanism that I'm building my payload from be manipulated like under 0 G? Is it accessible in the way that I think it will be, with the restraint points being, as designed? And then, if you take it a step further and then, you could even invert it, because we were talking at one point about restraints being on both sides of the payload, both next to the center structure, but also next to the restraint layer. Can I open it upside down? Like, those are questions that you don't really think about at all when designing for terrestrial systems.
yeah.
And um, yeah, there's many different tools that you can use to punch up the realism. But I'm with you actually. I The first time I tried that ISS experience, I got super sick.
Yeah.
Um, and someone I was reading online before I did it, someone was like, "Oh yeah, like, sitting down and doing it will get you more sick. So just lay down." And so I laid down and I put it on. I was like navigating like this, and yeah, definitely your brain adjusts, but only like when the headset was on. So when I took it off and I sat up, everything started spinning. And
Yeah.
then was
Yeah.
stuck.
Right. Yeah. I think for like a space training, if we didn't make ourselves like in the similar physics, like a similar environment as the whatever we see inside the headset, we will get dizzy immediately. I remember that time and I saw like why this is like an award winning and a lot of people give like 5 stars. I feel so sick. What's going on?
I mean, it's only a fraction of what's actually experienced, though. I mean,
Yeah.
it's Newton laws made manifest when you're up there in microgravity. Um, yeah, I think it's the most challenging environment that you can design things for, and to leverage technology to replicate that environment, but also to empower the individuals to not make mistakes in assembling the advanced assemblies that are to be sent to space. That's the cutting edge. I mean, you got to integrate technology along the whole process so that, we produce the very best product, whether it be a satellite system or a space plane, um, because there's no forgiveness in an environment like that.
Yeah, right.
And it's just anything that can be done should be done in
Mm.
terms of making it safe, making it performant, practicing and not costing schedule with small mistakes.
Yeah, because I think in space everything is pretty dangerous. I remember I saw some like astronauts go back to Earth. I forgot is that Hollywood movie or Netflix movie or the real thing, but I do see like somebody who I don't know whether this is true or not, but somebody who jumped from I don't know ISS or somewhere low orbit and use like a parachute and just like a jump and go down to ocean. And when I saw that, I was, is that real? Like
Yeah, so Felix Baumgartner was his name.
I forgot the name, but
Unfortunately,
yeah.
he just passed away
Oh.
not too long ago. But yeah, it was like a Red Bull sponsored thing where, he wasn't at all near ISS or anything like that.
Huh.
Uh, but he was extremely high up, and so much so they needed to use a pressurized suit and everything because
Yeah.
the atmosphere was so thin. But yeah, that feats like that, it's funny because like still you are designing for edge cases. Like no one has ever thought to do that until someone did. And the
Mm.
problem statement's not as simple as jumping out with a parachute, like that design of the system that would lift with the helium balloon and um yeah, it's all just way more involved the second that space or anything with uh decreased atmosphere would.
Mm. Yeah, yeah, I think it's very, very interesting. And also, what do you see like commercial space versus DoD, for example, like a non-commercial one? Like what do you see those two? Because we all know that SpaceX for me, it feels like it now is exceeding NASA. I might be wrong, but it seems like people or like all the efficiency, whatever they've already achieved, it feels like exceeding NASA. So what do you see more like government space industry versus more commercial space like what do you see those two? And yeah.
They're different missions. They're different missions with different problem statements, like we were talking about earlier, actually. Space as a warfighting domain is a problem statement that's only becoming more relevant, one that needs to be considered. And it is kind of overlapping with commercial um, technologies, like you mentioned, SpaceX and their deployment of constellation satellites, tens at a time. I think they might be even up to 100 at a time. I thought it was somewhere around like 50 or 60 satellites at a time, though. Um, that kind of deployment and creation of, an array of satellites is obviously powerful, both for, transmitting technology, but for other military purposes as well. So though we can sit here and talk about commercial space and space like DoD programs, the underlying capability is the same. And developing skill sets to benefit one does benefit the other, and implementation of one would exactly mirror into the other as well. So if you're looking for careers to go into, yeah, we can talk about individual companies,
Hmm.
but in reality, to develop a skill set of application of technology and advanced manufacturing is one of the safest um, you know, routes for anyone aspiring to work um, in space or in space adjacent fields. Maybe not so much astronauts because like Artemis, for example, an amazing mission to return to the moon. There's only a finite number of people who get to do so.
Yeah.
And, you know, if that's truly your calling, 100%, like, no, go 110% to get there.
Mm.
Um, those astronaut selection, those, processes to not only be, um, physically capable, but also educating. Like a lot of those people are doctors. A lot of those people are, um, you know, experts in their field, and then also astronauts. That's a beautiful thing. But I think to, you know, being in a space adjacent job is, in my opinion, just as cool.
Mm.
Um, it's kind of future proof, frankly, as we build out capability in both Earth's orbit, the moon's orbit, and then eventually onto Mars, which is the aspiration of SpaceX. People forget their mission is to be interplanetary.
Yeah.
Um, and that differs from NASA's mission, which is to, um, well, I'm not going to quote it because I don't know it, but it's to, benefit life with discoveries made in space. And that's
Oh.
pretty much Sierra Space's mission as well, to boil it down. Um, there are many technologies that benefit from microgravity.
Mm.
For example, protein synthesis, crystals, as well as, organ printing. These things suffer from gravity, and to potentially build organs on orbit where there's not the gravity to crush and cause cell death when you
Mm.
start, constructing organs. Um, that's it's going to be game changing, and I think people forget the benefits that space can provide us and kind of look at it as a, well, we aren't doing so hot or whatever um, in on Earth. Why are we going to space? And in reality, much like a lot of the technologies that have come about, um, critics don't see the bigger plan early on, and then will eventually end up benefiting from it later. But for everyone who's working in the industry, whether it be to protect national security or to, help provide the systems where the discoveries are going to be made to invent new cancer research,
Mm.
these things are, deeper rooted whys. Like, why am I doing this? It's not just for the paycheck, it's because I want to add to X.
Mm.
And I think whether it be DoD or it be commercial, there's way more justification, um, considering all the potential technological and scientific advancements ahead of us in space to launch, pursue a career in that.
Yeah, I do think that, for example, NASA's mission is pretty good because actually, there are a lot of interesting things happening. Or like, for example, I saw some, like a long time ago, I saw some experiment that NASA or ISS was helping, which is like bringing some cells that, for example, working with some university and partner with some professors and bring some cells or some stuff to space and see how they work, or see, yeah, like bring some plants to there and see if they can grow. So and I also saw some, like a machines, they bring like some rock or some soil from space or from moons, and go back and to learn, like just like you said, life, and maybe some cures for some disease, or more like a scientific research. Yeah, and as for SpaceX, it's like, oh, they are selling ticket and go to Mars. Yeah, and terrifying the entire thing. I don't know how it goes. Do you see any progress? Or
Oh, in terms of like terraforming and whatnot, it's to my knowledge a pretty it's a pretty out there in terms of like what's possible now. Um, what's not, and what would surprise people is that like Sierra Space, for example, has generated oxygen from regolith. That is the soil. It's not soil. It's actually like the dust on the moon. Um, what that gives rise to is potential generation of fuels, and
Mm.
so once we escape the gravity well of Earth, right? Like it takes a lot to up mass um, to ISS or to break to do an orbit around the moon, as was demonstrated in Artemis 1. It takes so much propellant to accomplish those missions. But if you're on orbit, um, you're out of the well of that gravity and able to more efficiently expend your propulsion, um, and obviously with minimal to no friction, you're able to accelerate and achieve greater distances. Like one thing that will be more critical to the space infrastructure of tomorrow is to regulate um, the deprecation of what's on orbit, to not fill our atmosphere with garbage, essentially, and to not let that garbage hit other garbage and then create tens of thousands of shards of garbage. That combined with designing satellite systems that are by design reusable, or can be given a new mission profile after refueling, or even there are several companies. Orbit Fab is one of them here in Colorado. Actually, I know the CEO, Daniel Lefebvre, and he's doing amazing things with refueling of satellites. I know Sierra Space actually is doing that as well. But if we're talking about the constellations of tomorrow and enabling space exploration, refueling on orbit is critical, so that once you escape your gravity well, you're able to essentially renew your source of propulsion and then continue along your mission. Otherwise, you will be just generating junk in space and essentially polluting not only our science in orbit, but also our science um, terrestrially. The more objects we put in space, the more noise there is for, our systems, radio telescopes or just visual telescopes to peer through, or to ignore the noise of. And it's deprecating our ability to perform terrestrial science if we are to just fill orbit with junk.
Mm. Wow. Yeah. So I think right now we have a lot of junk floating in the space. I hope there's like a like the trash can or somebody help out to clean up the space.
Yeah, yeah, like tugs and junk capture are the mission statements of several companies as well. Like it's definitely front of mind and will become hopefully more viable to keep us um, keep us agile in low Earth orbit and beyond.
Yeah, yeah. I think there are a lot of interesting things happening. And may I ask you what types of jobs adjacent to space? Not like, for example, like as far as I know, astronaut, you need to get a pilot license, something like that. You need to learn how to fly. Yeah,
Yeah, I
yeah.
mean they're not. They're very often not actually piloting anything, but yeah, no, a lot of pilots do go on to become astronauts, or at least in astronaut programs. What what's I think more attainable by people and young people especially. I have a company called Engineered Reality, and that company's mission is to essentially empower um, mainly right now students,
Mhm.
high school students, with the knowledge of advanced technology such as XR and AI,
Oh.
uh, to bring them to the forefront of technological innovation so that those are just the tools they know how to use. So in whatever job, I think it should be in advanced manufacturing for space, but it can apply to anything. um, they are able to assess their environment and then be that first line of defense for, yes, that's a good use case for technology, or no, it's not. And, to, instead of trying to pick the sledgehammer of technology and big data, instead to design a smaller tool like your little ball peen hammer for fine work. That right there, and viewing technology as based in the reality of, hardware, edge hardware, um, scaling of compute, and fine tuning. And, there's everyone talks about AI
Mm.
as this, broad strokes kind of problem or solution.
Yeah.
And in reality, you don't understand your problem if you think that something so broad can solve it. Um, we just haven't reached people say then that's what AGI will be for, right? It's like, well,
Mm.
we're not all going to have AGI in the palm of our hand. What we do have is architecture where we can, search through knowledge that has been accumulated by our coworkers.
Mm.
If we amass the knowledge of everyone in all of our documentation and provide it to each individual, both, in the palm of our hands, at our fingertips, and even in front of our eyes, that right there is going to solve some amazing problems, because unfortunately people retire. Um, and those people typically have the most experience, and
Mm.
you're not able to easily replace them.
Yeah.
And frankly, we're kind of in approaching a workforce crisis where um, we're going to have people with um, essentially a treasure trove of experience and information uh, retiring at greater and greater frequency. And those replacing them, a paper degree doesn't get you anything.
Mm. Yeah.
I stress this, and it is kind of critical to let students know, yes, college is a good aspiration. However, it is not, the end all be all. You can solve problems and you can demonstrate technological expertise without needing that sheet of paper. And in fact, a program here put on and managed by Kelly Reeser through Colorado Department of Labor and Employment seeks. Are we back?
Oh, yes.
Oh, sorry about that.
Yeah.
There was the camera shut off.
Don't worry.
Um, okay, let's see. Where are we? What was I saying? Ay, ay, ay. Oh, yes. Colorado Department of Labor and Employment and Kelly Research Teacher Externship Program. And the entire premise of her program is to take educators, high school educators, particularly in STEM, and place them in, um, technological um, shadowing experiences, whether it be in aerospace, in quantum, advanced manufacturing. All of these things are critical to provide insight into for the educator, so that the educator can then take the lessons learned and the knowledge perspectives gained, really, and bring it back to the students. In that program, um, it's so impactful because um, like the teacher that I was doing with Shane, not only do I get to relay, this is how we're using XR, this is how we've evaluated use of AI to give him so that he can, let his students know that here's how tools are being used, here's how, I should tailor my curriculum. But also the other way, how I can learn to be a better educator from him and bringing that, kind of niche knowledge of XR and AI to my company and to others is just as important because you can be the smartest person in the room, but if you can't communicate it,
Yeah, right, right.
you're, yeah, you're lost. So programs like that are the future and they're empowering the future workforce. And that's why Engineered Reality, my company, is fully dedicated to, um, you know, putting technology in the hands of the future workforce,
Mm.
allowing them to gain the level of familiarity, but also the depth of understanding so that, maybe they don't need to go spend $100,000 on an education um, because the reality is now differentiating yourself by degree is really not an option anymore. Even in engineering, like your mechanical engineering degree is not as unique as, maybe it once was. And I'm right there with them. So, our superpower is learning. It is evolving to take technological advancement, synthesize it with or creative problem solving, and then implement it um, with you know extreme what is it? What's the word? Prejudice. With extreme prejudice, and that's like not to say prejudice in a negative sense, but to say this problem that I've tailored, or this problem has a solution that I've tailored, and to you know go beyond that to try and be like, well, why don't we just use XR for everything? It's just like, well, why don't we use AI for everything?
Yeah.
Because it's just a fundamental um lack of understanding that I think the industry will soon wake up to. Whereas every company saying AI powered and AI informed, and
Mm.
it's just no longer going to impress anyone.
Yeah, right. I think right now, people start getting tired of AI. If things is being made by AI, it becomes cheap. Yeah.
Yeah. It's also, it can be a source of laziness. Like, I was speaking with some individuals in a company. Uh, Actually, I'm not going to name, but they were talking about object identification, and so object identification, they were seeing people that they were looking to hire,
Mm.
essentially saying, "Oh, well, I just feed AI, like I just
Yeah.
ask AI." It's like, oh, well, this is it's like a mathematical problem. It's not an ambiguous kind of immaterial AI question. It's
Yeah.
something that should be calculated. And in fact, that's what AI is doing. But to, again, use the sledgehammer of AI for something that's a delicate operation, especially if you're trying to object detect on an edge device with limited power and limited computational ability, it's like, well, that could work, but your problem solving with AI is frankly lazy. If that's like your fallback, you need to educate yourself. I'm sorry.
Yeah, no worries.
Being here, it's getting kind of warm. But yes, I think empowering the workforce of tomorrow and also those currently in the workforce with knowledge of, um, the fact that AI is just math, and the math under your broad strokes AI can be implemented in a more pointed fashion, particularly for computer vision use cases, is something that need not be forgotten because otherwise we'll just all end up building data centers and consuming energy until, you know, we run out of coal to power all the turbines that's generating the electricity.
Wow, this is very interesting. So yeah, I do think that, for example, like AI, at the beginning we think this is amazing, right? But the more AI that being automated, especially I think customer service, I just want to talk to human because every time when I get into the chatbot and I keep getting myself looped, I even type to the chatbot, can I talk to human? And it says that, oh, if you want to talk to real human, we will use human. It will be human. Use email to talk to you. It won't be instant. I was like, oh God. Before, if you talk, I remember when I talked to BOA Bank of America,
Mhm.
before it's easy, much easier. Before AI, it's much easier to get human to talk to you and solve all the problems immediately. However, right now you need to say something else to trigger that human thing. I remember I called like 5 times, and at the end, I find out that, oh, you need to say that your credit card lost. Even though I just want to change my address or phone number that I couldn't edit on my own, but I need to say something extremely serious that
Yeah,
machine cannot solve, so I can talk to human.
yeah, it's wild.
It's very stupid. So yeah, I know that a lot of a lot of website that they said that, oh, customer service is probably the first one, or call center will be the first one being automated. But I do
Mm.
think that the reason why people call customer service is not because of the simple questions that AI can solve. It's more like a super complicated, or they couldn't, or some special occasions. So
Mm.
I do think that if we use AI for everything, and even you see like a AI for 3D model, it's kind of like a mediocre if you text prompt.
Oh,
It's
best, yeah.
yeah, or like a text prompt to video. I mean,
Mhm.
it's somehow for someone who doesn't have any equipment, use zero budget, $0 to create that is great. But compare with, the real human, real shot. Recently, I just talked to, friends about like, if you see movies in the past, the movies feels much, much better, even though there are not a lot of like a high equipment, like the professional film or VFX. But
Yeah, yeah.
the story was so good. And nowadays I couldn't even remember what movies is that. It feels everything was being written by ChatGPT or something. You just couldn't feel things anymore.
Mm. Well, I think it goes back to, generation should be applied in a very um it should be applied very carefully. Generation of anything, whether it be, fake pixels and CGI. It should be generation of text with LLMs, generation of just straight up video with any of these, Sora or any tool like that. Because what you end up getting into is this kind of like state of fever dream where what you're reading or what you're ingesting with your eyes or hearing with your ears seems to be of substance, but it's only mathematically optimized to seem substantial.
Yeah.
Otherwise, like you're just not really consuming anything real that someone put time into, or
Mm.
in the event of the videos, like I've done a lot of experimentation with videos and going from text to video to mesh or to Gaussian. Um, it's kind of the future of entertainment, and in a way though that I don't really want it to be, no matter how good the generation. Um, Videography and photography is an art. And like, I mean, it's funny because like that's what my dad does.
Oh,
He got me super interested in photography and videography. And it's funny because like I chose a very visual medium to become, you know, an expert in, that is XR.
yeah.
However, the impact of AI is so large that it's encroaching on creatives' workflow. Like
Mhm.
no longer like for example, Gaussians, like recreation of environments in photorealistic manners, including all of the reflections and transparent elements and all this stuff. It's becoming more possible. But photorealism, when it's generated from a synthetic data source, a generated source,
Hmm.
it's not the same, and you can immediately see it. It's like I said, almost speaking of cameras. Sorry, Pop. Just keep cooking this one. No, but I think you know, my father's um interest in photography and videography and maximizing the quality of his output and his passion for it really inspired me to not only, exercise everything I do with most quality that I'm capable of, but also visually to storytell, to impart purpose with that which I create. And, I think it's a shame. It's both powerful and it's kind of a shame that I think in the future all you'll have to do is to sit down and then generate video of a beautiful place,
Mm.
of a historic place.
Yeah.
I don't think that's a good use case. Instead, I think going to procure your own, data, your own video, your own pictures of that place, and then reconstructing it, and then using that and the detail that you captured to storytell, that's powerful. And it will always be more powerful than synthetically generated um, video or images, because I I think that eventually there will be a degree of regulation for usage of synthetically generated video and assets that
Mm.
you're going to need to put, this was made with AI or something like that, where you will never get that feeling like you mentioned of old movies,
Yeah.
real.
Yeah. For example, like if you see old movie, the lighting, it feels real versus you do the, VFX. Because right now, if you see Netflix, whatever you see, it's pretty much a lot of VFX, just trying to show like the skills of how they can handle the image or the surface, or like the the creativity is more like you need to post effects. So yeah, and the storytelling maybe is because we are running out of ideas or something, but it just feels like right now, for example, in Netflix, do you see any recent movies or videos, TV shows that you feel like, wow, this is a classic, or like this will go, beyond time? Yeah. So I,
Well, I think it has to do with speed. I mean, in this day of synthetic generation, to go to market with your product, i.e., a movie or a series, um, quickly is all that is at the front of anyone's mind. It's profitability
yeah,
and speed over quality
yeah.
and fidelity.
Yeah.
Actually, I'm rewatching the Lord of the Rings series, the extended versions, with my wife right now, and the shots that were actually taken to, tell the story of Middle Earth,
Mm.
I'm just like sitting there, like I paused, and it's like this is amazing. Obviously, there's world building that you have to do with synthetic set generation and CGI and whatnot, but practical effects and on-site shooting and, videography and photography at its core, I don't think will ever be replaced, and we shouldn't aspire to, because we would never go anywhere or see anything beautiful. Um, because we could just generate it ourselves and throw on a headset and be there.
Mm.
And in reality, it will only ever be a synthetic experience instead of going and partaking in the adventure to go, truly experience a place.
Mm. Yeah, I think AI is a tool, it's a very powerful tool, and see how you use it. Yeah, I mean, it is just I think the world will be very different from what we used to be. So yeah, I mean, I agree with what you said that yeah, like the things in the past feels much more um I would say um I would say I don't know like much better in the past. Cool. Yeah. So what's one thing that you'd like to share that we haven't touched on yet?
Hmm. I think I'm just very focused at present to kind of fight the dread that comes along with the replacement of um, introductory positions in the workforce with AI. I would say, um, and as someone who has a certain degree of expertise in local AI and extended reality and you know computation simulation, the the technology will never advance to a point where a human is not needed.
Mm.
It's only changing the way in which the human is needed. Um, and for kids to look at, like, oh, my comp sci degree is not worth anything because, all the low level coding is being done
Mm.
by AI. Well, it's then up to you to hone, like you were saying before, hone your natural language programming skill, become an expert in process to the degree of the you being able to spin up multiple agents, and code across the entire code base simultaneously, because your knowledge of that process is so in depth that you're not the one typing out the code, but you're the one essentially guiding and then quality checking. um, Purposeful creation, I think, will shift more towards um, quick generation, quality testing, and then implementation. And implementation is the fun part, but quality testing is going to be much more critical, um, because we're filling all the app stores, all of the online repositories of video with just AI slop,
Mm.
and um, you can use the tools and still produce beautiful things, still produce useful things. So
Mm.
my, um, you know, my message that we haven't really touched on goes out to those just entering the workforce or just imagining, are these jobs even going to be around? And the fact
Mm.
is, yes, just bring your creativity,
Mm.
maybe not technicality in one language or another,
Yeah.
but your technicality will become knowledge of process and
Mm.
your creativity combined.
Yeah, I agree because I think right now, um, every week there's always a tool that can pretty much innovate or disrupt the entire industry, right? Like ChatGPT, right? ChatGPT 5, considered to be like a lot of doctor degree in level in a lot of fields. So yeah, so what can we do, right? Like as for example, for a teacher, I was thinking about wow, for a teacher, if you see that student, do you think the students want to learn just from the knowledge, or they want a human to talk to them, right? So there's a lot of things, or nursing. Do you want a robot to take care of you, or
Yeah.
human come to your room and talk to you? Yeah.
Yeah.
So yeah, so I think there are definitely a lot of things that we can use AI to help us. I think yesterday or today I just saw in China they just launched a female robot that can pregnant and bear kids for you. So I just saw a robot and I saw a human baby in that robot, and it seems like they are manufacturing for a lot of that types of robot to bear or to give birth to human children. Yeah.
No, I think just because something possible is possible technologically does not make it right. Um, and that goes to extremes, like you've just said, but it is also something that, as a society that we'll need to consider and be very swift in correcting when that boundary's been stepped across. I think we're accelerating towards those boundaries in all directions all at once, and yeah, we need to be very careful in terms of the ethics of technology and what can be generated, what can be
Mm.
accomplished.
Yeah, yeah. I think the world is changing so fast, and AGI, I don't even know because I remember I read the book called the what's that name? Singularity, right? It means that when it starts, it's the end, which means that yeah, human. Yeah, once the robot knows that the problem is human, then they will do something, right? And they are smarter than us. So yeah, and it seems like AGI will be around or like a welcoming within 10 years, a decade. So yeah, I still don't know what will future be in a yeah for in my lifetime. But yeah, I think it's still remain positive and then use, I would say, learn AI as much as I can, because I think you know it, you know how to use it, you constantly use it, so you know if you get familiar with it, so you are not like a, you know, in the world that is ignorance. And we know AI is good and bad, and we want to use it for the good side. Yeah.
Yeah, I mean, treating it as the tool that it is, it's part of your tool belt. It is not a replacement for your brain.
Mm,
Um,
yeah.
your it really should enable you to become more technical in that you go back and just like the saying, if you want to know the future, read the histories.
Mm,
Um, you need to understand where this type of computation or where this specific algorithm or the specific method came from in order to implement it correctly now. And it's not as simple as saying, to chat GPT, implement that algorithm. No, it's like you have to understand what the effective use of your tool is in order to accomplish your goal. And
mm,
so I think with people right now just trying to one shot everything,
mm,
it's lazy and it doesn't actually solve any problems. It's technologically impressive only to the degree that, it's extracting that which has been done before out of, uh, you know, matrix math, which is trained on, the knowledge of the world. But if you want to do something um, truly innovative,
mm,
there will be no replacement for adduction. Uh, Induction and deduction are mathematically, there's algorithms for, but adduction, like actual invention, is there's no algorithm for that. So people saying like AGI will replace humans completely
Yeah.
are they're delusional.
Yeah,
Um,
I do think.
there's no mathematical algorithm for invention to create nothing or something new from nothing is not mathematically possible. Um, so I think to that degree, it's like AGI's usefulness will not be in replacement of humans. It will be as a companion, a tool for humanity. And everyone who says otherwise is just on a hype train that they don't understand. And they don't appreciate that everything underlying this technological advancement is just math.
Yeah, yeah. I do think that I think it will be AGI will come, or I don't know, will come in my lifetime. It's 10 years in my lifetime. So yeah, we will see. And it seems like a lot of leaders, they are giving a lot of very like scary types of prediction. But I think as long as we can keep up and we can use the tools in our advantages, right? Building things or learning and improve ourselves. And I think we should be able to still live, survive in that, I don't know, AGI or AI era, like the futuristic era. We should be able to. But I don't know. I just saw like a China, they have like a woman give birth to child, like the robot woman. Um, I was like, wow, in the future that everything you can ask robot, if a robot can give birth to child, then what types of things is impossible? So it becomes very
Yeah, you get into kind of a matrix kind of scenario. Like
yeah.
that was so far ahead of its time for so many different reasons. But
Yeah,
um,
becomes matrix. We are the little human babies and being nurtured by a huge machine types of thing.
yeah, I mean, we'll be plugged in, and the reality that we are observing is generated already. It's weaponization of media.
Yeah.
Uh, Apart from that, once we make that media even more addictive than it is today,
Mm.
which is one of the things that my friend, the teacher who came and externed with me at Sierra Space, has made the comment that he just can't get kids off the phone. Like he can't get them to engage.
Oh,
And
yeah.
once you throw AI tailored, algorithmically tailored, and AI generated media in front of kids, it's over because you're completely capturing and captivating in a way that's tailored to the specific individual, and it's this feedback loop of what you like to see and what you like to hear and what
Yeah.
it's deadly. It is. You're not living in reality anymore.
Yeah.
um, and that's what we have to fight, and that's what we have to I maybe I wouldn't go as far as to regulate, but I know for a fact that um screens and content for children are proven clinically to be dangerous and to really inhibit both social growth and even cognitive growth. And to think that we're completely exempt from the same as adults and young adults
Yeah.
is delusion. I think that it's equally as dangerous for us because if we're just all going to live in our own made up worlds,
Yeah,
um,
right.
feeding us exactly what we want to see. Like even like a Wall-E kind of world where, we're just always engaged and just sitting there fat, dumb, and happy.
Yeah.
Uh, it's not a way to live. And if there is to be, as you say, an AGI within 10 years, I hope it is um, positioned as a tool, like as if it is to be, a not a cataclysmic event, it will be enabling of humans to live real lives and to reduce the amount of time that we engage with fake and virtual um, distraction.
Yeah.
Like hopefully it allows people to just live um, in a much more organic way because our biggest problems are being worked on, or we're working on the problems with AGI in a much more efficient manner.
Yeah, yeah. I think the future is coming. It's coming. AGI is coming. But I think how can we utilize it, learn it, and not afraid of it, and trying to, because right now I would say we are the lead, right? We are leading the direction, how the world is going. So if we can make sure the technology, we are choosing the good side instead of bad side. We all know there's always good and bad side. So if we use the technology in a good way, then yeah, we can definitely help make the world a little bit, I would say, better than before. Cool. Yeah. So um, yeah,
There we go.
no worries.
Sorry about
Yeah.
this overheating issue. It's killing me.
Oh, 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 I see. No worries, no worries. I mean, because this is like the virtual, virtual interview. And
Yeah.
it's great that, it's overheating. So this episode is definitely not generated by AI because it's not perfect. It's a real human. There's a real issue. AI won't have any like a screen heat. It will be
Yeah.
perfect. Oh, yeah. So that's it for this episode. Thank you for listening. We release episodes weekly. If you enjoyed this conversation, check out our episodes on Spotify, Apple Podcasts, or YouTube. Support us by giving us a follow and a 5-star rating, or subscribe to our channel and give this video a like. Thank you and see you next time.